Science. Hi, everybody, and welcome to this edition of Mad Scientists. I'm Miss Kathy, and here is Miss Caroline. And we will tell you this, the reason we are allowed to stand kind of close to each other is we have gotten our vaccinations. Woo! We're good to go. So we're real happy about that, and we hope you guys can get yours too if you can, okay? All right, so what are we doing today? I don't know. Let Miss Caroline start the explanation.
So today we are going to experiment with tornadoes in a bottle. So you might be wondering how we're going to be able to make this happen. Well, Miss Kathy will do the experiment, but I'm going to explain a little bit more about tornadoes first. So if you've ever seen a video of a tornado, you know that they can be very large and very violent. They're very destructive. They are one of the most destructive types of weather. So of course, next to hurricanes and then large bits of hail, they can be very dangerous too. Yes. So to get a tornado, a few things need to happen all at the same time. So a large thunderstorm needs to be forming in a cumulonimbus cloud. So to define that, these are large, tall clouds that usually have something of a shape coming out like an anvil. So you've seen it and it kind of looks.
Yeah, it's flat on the bottom and kind of poofs up at the top.
Yeah. So a thunderstorm needs to be forming in one of those types of clouds. A change in wind direction and high wind speed at a high altitude needs to cause the wind to go horizontally. So it needs to go this way. So think horizon horizontally. Okay. Rising air from the ground needs to push up, swirling the air. And then this causes a funnel to start sucking up more air. And then finally, that funnel that forms needs to touch the ground. So that's the final thing that needs to happen before it's a tornado. So because all of these things need to happen at once, it just so happens that in the Midwest in the United States, that's the perfect grounds for tornadoes to happen. So you sometimes hear the Midwest called like Tornado Alley. That's because that's kind of where all of our jet streams meet in the United States. So you've got one coming from the southwest. So let me point from your direction so you can see it. So southwest is this way. Okay, one's coming this way. One's coming down from the north with cold air, and then one's coming kind of from California. So all of this is kind of swirling right here. So all of these states right here in the middle, that's perfect tornado area. All right, so some other characteristics of tornadoes are the shape. Tornadoes are funnel shaped, kind of like a wedge. Think like an ice cream cone, the pointy ice cream cone. So
Not a fun one.
no, not a fun one, not at all. Okay, size, they can vary. Some well, let me start over. A typical United States tornado can be 500 feet across. So that's about the length of 12 average sized school buses. Pretty big.
Ooh, that's horrible.
Yeah, but some can be as narrow as a few feet across. And then some can be as wide as 2 miles across. So there's a big range. So you can see how destructive they can be. If you have a tornado 2 miles across and it runs for 2 miles, everything in its path can be destroyed. Not good.
No.
All right, so wind speed. Wind speed also varies. They can be anywhere from 65 miles an hour to 250 miles an hour.
Oh my gosh.
The color can change varying on the environment. So you can have anything from a pink tornado to a gray tornado. We almost had a green one today. Yes. Kathy will explain that one. And the rotation. So when viewed from above, say like from the International Space Station, tornadoes in the northern hemisphere are going to rotate counterclockwise. So that's backwards clock. Let me see from your direction this way, I think. Yeah, okay. And southern hemisphere, so think Australia, that they're going to go clockwise. Oh, this one.
We got
Clockwise, counterclockwise. Okay, so fun fact, toilets also flush in those directions too in the northern and southern hemispheres. All right, so tornadoes also have a scale, kind of like hurricanes, that measures how fast and destructive the tornado is. This scale is called the Enhanced Fujita Scale and is usually abbreviated EF. And the scale goes from EF0, which starts at about 65 miles an hour to 85 miles an hour. And then E5, which is over 200 miles an hour. The highest winds observed in a tornado in the United States was the El Reno 2013 tornado, which got up to speeds of 336 miles an hour.
Whoa. Whoa.
And just for reference, the average NASCAR car drives at about 200 miles an hour. So that's pretty fast. That's pretty fast. All right, so to recap tornadoes, the factors that need to be in play for a tornado to happen are forming thunderstorms, a change in wind direction at high speed, rising air, a swirling funnel of air, and lastly, it has to touch the ground. All right, so that's all I have for tornado science. I'm going to hand it over to mad scientist Kathy for the experiment.
Thank you, mad scientist Caroline. All right, so first thing I'm going to tell you guys what I did here. We take 2 bottles that are the same size. You find a washer that will fit over the lips of the bottle, because what it's going to do, it's going to reduce the size of the hole. Okay?
Can you show?
Yeah,
Can you see
washer's
that?
in there.
Okay.
Maybe. Yeah. All right. And then you fill this bottle with water and food coloring. I had green food coloring in here last night, but overnight it magically disappeared. So I don't know how that happened. Maybe that'll be another experiment, but we'll be able to see what happens. Okay, so we've got this full of water. You could put some glitter in there or something. Miss Shauna doesn't like us to use glitter in the library, so we didn't use glitter. What's going to happen when I flip this? This bottle's full of air. So when I flip it, because the hole is a little bit smaller up here, it's not all going to rush out at the same time. It's going to come out kind of slowly because there's air in here filling up the space. When I flip it and give it a little swirl, like mad scientist Caroline said, that gives those conditions for that tornado to start, then you will see a tornado start in this top bottle. But it's going to be more like a water spout, since we're not making it out of air, we're making it out of water so you can see it. All right. So if Miss Shauna would just come in a little closer and stay focused on the top bottle. Let's see if we can get this to work. Okay, so there's really not much going in there, but let's give it a swirl. And there you go. Look at that, guys.
Oh, that is cool.
Isn't that awesome?
So I can definitely see how this is working because the air from the bottom is coming up to the top, and so it's making that vortex.
Exactly. We'll go ahead and flip it again so you can see it again.
Oh, that is cool.
All right, so let's give that another try. Let's let all the water settle in the bottom. Okay, so now, guys, we've got air in this bottle. All the water's down here. We're going to give it an easy flip. And you can see the water doesn't come out that fast in the bottom, right? There you go. Ah, there it goes.
Oh, yeah.
Ooh.
That's pretty cool, isn't it,
Yeah,
guys?
that is cool.
That's neat.
And this is a real easy experiment to do at home. The first time we did this, just make sure you put enough duct tape around the bottles so they don't leak too much. But there you go. We have successfully made a tornado in a bottle. Yay! All right, guys. Next week, we're not going to really have an experiment, are we, Mad Scientist Caroline?
No, we're not.
We're going to discuss the beginning of our summer reading program and how we're going to kick it off. And it's going to involve a fire department bucket truck and a bunch of eggs. You'll have to tune in next time to find out what we're gonna do and what you're gonna do to help us out. So until then, we'll see you soon. Are we ready to go and start?
I believe so.
Yes, we will let you know about the eggs.
Mad,
Science,
mad.
science.